Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you for attending our talk this afternoon and mini tutorial on Trident, a scientific workflow workbench, which is something we're developing in our team. Our talk will run roughly 2 hours, and you're welcome to ask questions throughout, but also keep in mind that we're more than happy to do even deeper dives in what you're going to hear today, either after the talk. We also have a demo that's actually in the eScience conference itself. But again, questions, clarifying questions, or just something you're curious to ask, please feel free to inject during the talk. I'd like to say first a few words about the team. We actually have a dual development team. The primary early prototypers, architects of the team are in Redmond, Nelson Arujo, who'll be speaking, myself, Dean Go, Jared Jackson, and Nitin Gautam in Redmond are doing the advanced prototyping and initial development and architecture of Trident. Yogesh Simon and Catherine Van Ingen in our eScience group are actually actively deploying Trident for an eScience project to give us feedback and actual requirements. But once we've actually articulated the requirements, we hand it off to an offshore development team of about 12 people. Joby Thomas and Aditi Technologies and the development team where they're actually doing the actual development testing to make what we hope will be a robust platform, something we can release to the community. In addition, we've had a great number of contributions from our summer intern crew who joined us last summer, who actually, in addition to doing research on our Trident platform, actually came up with some very interesting features, all of which we hope to get into the system, namely Aaron Chinthaka from Indiana University, David Koop from the University of Utah, Satya Sehu from Wright State, and Matt Valerio from Ohio State University, where our summer interns working on Trident who did some great work as well, so we thank them for their contributions. A little bit about our talk today, just the technical content. After I do a brief introduction, introduce a few things, I'll turn it over to the guys who have done the heavy lifting on the project to give you a feature overview. Dean will present a feature overview and logical architecture of what Trident is. The guys will then do a deeper dive into select features with demos so you can see Trident in use and get a better understanding of how those features are being built and what they actually do. And then we'll close with a roadmap to delivery of when we're actually going to be releasing this to the community, so you'll see how the features are being added and give you a sense of the schedule. But just to share with you, and something which should come through time and time again, a little bit about our design philosophy and our exit strategy for this. Please come on in, guys. Come on. Plenty.
You're looking for the back door.
No problem. We're just getting started. No worries. What started, one of the major design philosophies for this project is that we want to leverage a commercial off-the-shelf workflow management system for scientific workflow to the extent possible. 80% of the development we feel that goes into a workflow management system is building base functionality. We want to leverage a commercial tool that's available for free, Windows Workflow, and we also know that it's going to be adding new features to it over time, so we're going to piggyback on that development. What you're hearing about today is we're building only services and features for scientific workflow that are required for scientific workflow. That's what our team is implementing on top of Windows Workflow, and that is what we're going to release as open source. We know we're not going to get it right the first time. Feature requirements for scientific workflow are evolving. A lot of thought has been going into how to make the architecture extensible. You want to pull out the provenance model and put your own in, you should be able to do that. You even have the source. We also want to make sure that we integrate with community tools. Many people here are probably familiar with My Experiment, which is a growing momentum behind using that for archiving of workflows. We look for tools in domain-specific communities or broader workflow community to try to make sure that we integrate nicely with them. We're going to use them and make sure that works out of the box. In order to scope this effort and keep it from just turning into a scorched, burn the earth, boil the oceans, we're actually deriving our development from actual eScience requirements. And I'm just going to talk about 2 projects we're using to drive our development in terms of making sure it works for those 2 projects and take a commitment for them. Finally, we're going to be looking at early 09, delivering this as an open source accelerator to the community. So again, you should be able to pick up all the source code for this. There's a binary version, there'll be documentation, and you can start to add your own functionality, if you will, for your domain or for your users. Let me just say a couple words briefly about the 2 eScience projects we're using and we're leveraging on and why we chose them. We were very motivated to do scientific workflow by Jim Gray, who noted that the oceanographic community desperately needed something like this to do workflow to read from sensors coming off of something called NEPTUNE, or the Ocean Observing Initiative. and that workflows could produce on-demand visualization for the scientists. And what was unique about this application, it's highly interactive. The scientist is looking at a visualization of the ocean. You'll see that demo running later today. You don't see workflow. You're kind of interacting with a virtual Earth, if you will, for the ocean and doing on-demand data product generation. Highly visual, highly interactive, and highly creative. You're meant to be able to add new workflows and activities on the fly. And much like in Jim's approach to actually build the workflows for that and understand the authoring experience, we asked the scientists, what are the 20 workflows that you want to run? And from that, we started to realize there's common data sets that you need to be able to do, data manipulation, data sites you have to read. There's high-end visualizations you have to produce. And somewhere here in the middle are a series of activities or operators that have to be part of your workflow library to do data manipulation from source to visualization. The end result is, you'll see some of that today, you end up with this highly visual environment producing things that the scientists understand, all being driven by the workflows you've authored based on activities in these libraries. But again, highly interactive, pretty much looks like you're playing with a visualization system. The second major project was PanStars that Yogesh Simon and Catherine Van Ingen are acting as point for in terms of workflow requirements and actually doing the delivery of it. PanStars is one of the largest visible light telescopes, 1 gigapixel per telescope, and it surveys the entire visible universe in 1 week. This is really a big data loading workflow. But they're actually giving us very crisp requirements on loading and merging of databases with workflows, how to execute workflows over clusters, unlike what we're trying to do for the NEPTUNE project, that we need to have strong workflow monitoring of the execution and fault tolerance, logging and rudimentary provenance, and how to handle faults. So again, this is where we're getting all these requirements to build what you're going to see during the course of today. This was just a snapshot. Yogesh is here, and we'll be talking tomorrow, I believe, Yogesh? Is that when your talks are scheduled? On PanStars and eScience poster. Okay, but these are some examples. These are just high-level views of the loading and the merging workflow. Where you can see detecting loads, launching recovery operations, and providing monitor or management capabilities over those workflows are all part of the requirements. So again, this is what we've used to drive what you're going to see here in a minute. So before I pass it over to Dean to actually talk to us about the logical architecture and features, I would like to point out we just within the last few days got a technical writer to stop and build a web page for us because we want to start having some external presence to share things with you. If you were to try to hit the site, you'll have to use a beta here in front of this site. This is the URL for it. It's rather lengthy. We'll work on getting that cut down. After January 9th, when the site goes live, you can drop the beta out of it. But the most important thing here, we're going to start putting PowerPoints, perhaps even binary drops, videos about Trident in use, and you can actually sign up if you want to be notified when releases are available. But we're going to start having a little bit of a presence and a dialogue with the community. But you can start reading some stuff here, and if it's scruffy, I apologize. We're just like 2 days into it, to the writing of the website, I should say, excuse me. So with that, I'm going to turn it over to Dean to talk to us about the logical architecture.
Yeah, good afternoon. I'm a program manager in Roger's team. My responsibility is to work with the offshore team and then responsible for software specifications based on user requirements and figure out the priorities, milestones, make sure we're on target. First, I'm going to cover the Trident logical architecture. So this is a diagram that has all the major pieces displayed. And I want to point out, like Roger said, in Trident, we only build what's required. We are building Trident based on Windows Workflow Foundation. Windows Workflow Foundation is part of the .NET framework, so it's a commercial engine. There's a separate team does this product, so we closely work with them. They actually have a body assigned to our team, so we work them closely. We can get the latest updates and so forth. And based on the Windows Workflow Foundation, we build designers, so scientists can build workflows. And we also have deployment packages, so the workflows can run. And then during runtime, we have management tools for workflow management, monitoring. And we also want to share the workflows to the community so that they can have social annotations and comments. And again, we're now trying to build everything, and we're collaborating with my experiment portal so that we can export workflows to my experiment worksite. And the unique runtime services we're building include workflow execution host. That's where the Trident execution engine is. It wraps around Windows Workflow Foundation. And we have a publish, subscribe, a Blackboard. Jared is going to cover the technical details more. So this is the service that serves as a communication hub among services. So all these services are decoupled. For example, if we want to capture provenance data, we go to the provenance service, goes to the Blackboard to subscribe data, and then stores the data into provenance store. More importantly, you can write your own service, and then you can plug into the Trident runtime, and then you can subscribe data without impacting other running services. And Trident Registry is a catalog of all the workflows, services, the data products, and knows everything about workflow, activities, input parameters, output parameters, how they are related, and it's fully integrated with the designer. So users can browse workflows based on from the registry and see its own workflows. And registry also used by monitoring process, used by management tools. So this is the a kind of the brain of the system, and that supports different data stores. So it has a data model that is database agnostic, and it's a database agnostic. So out of the box, we support SQL Server and CloudDB. CloudDB is SQL Server data services. It's from Microsoft. And if you want to plug in your own data stores, you can customize the data provider. For example, you can use Amazon's M3 or other data stores, and you can do that. Out of the box, Trident comes with prepackaged libraries, activities. We realize we are not going to cover everything, but out of the box, we have these. You can use this as a sample reference implementations, and you can modify them, you can extend them. Most importantly, you can add additional libraries. We have a framework. You can add more and then build your own libraries. And because we have a registry with rich set of workflow metadata, this allows users to add additional metadata to the workflow. For example, if you want to do versioning out of the box, we do versioning. And if you don't like it, you can also modify it too. And workflow packages is like a container. So a workflow package will contain a workflow description and all the related runtime libraries and data input files. And it's anything that you want to do to repeat the experiment can be put into a workflow package. And the package will be a zip file. So Trident users can share them so they can repeat the experiment, and they can also do collaboration. And not only we want to make the package available to Trident users, we can also make the package available for non-Trident users. For example, if you want to just look at what the workflow does, you can look at the workflow package. And those workflow packages can be programmatically interpreted. It's not like you have to manually look at a package and see what that is. And we have a flexible programming model for our Trident. A developer can use Visual Studio to develop custom workflows and activities. And then you can just import it to Trident to take advantage of a Trident runtime. For example, logging, monitoring, provenance. And as a scientific, in the scientific community, as a scientist, you may not be comfortable with using Visual Studio. You want to use Trident Composer. So Trident Composer is a visual authoring environment. It's not a programming environment, but we don't require programming, scripting. The user experience is drag and drop activities to the designer surface, and you connect them, and you make a workflow. And in this example, you can see that in Trident, we add some unique activities. And again, if you don't like them, you can customize them and make them behave differently. For example, in the for loop, we have a start value, end value step. And within the for loop, we embed a workflow. This is the workflow, and this is represented as a subsection. That means within the subsection, you can have other workflows. And you can customize the look and feel. And then you can also do some other loops, like a while loop and other loops. And this one is an example of if and else. So for example, you can compose conditions graphically and without any programming experience. And again, this is a very Trident-specific feature. After workflows are developed, you want to run the workflow. So we want to be able to develop once and then run in different environments, either locally and remotely. Currently, we support high performance for computing clusters. So that means once you develop a workflow, Trident runtime services is going to support Microsoft high performance computing platform. It can run in a cluster environment. And out of the box, we also support CloudDB. And with the advancement of Microsoft service storage, so we're going to keep adding new capabilities to the platform. And during runtime, there are two kinds of workflow experiences. One is during a workflow can contain some activities that can have a UI pop up, for example, that requires some user intervention or graphic display. And that requires a runtime service can support those displays. And sometimes a workflow runtime just runs in the background. And we support both modes. And Trident runtime automatically figures out which mode the workflow is and then determines what mode should do. And we have this publish subscribe system. So the execution service publishes data to other systems. That means tracking services, provenance services, and monitoring services, they all can subscribe data from the execution service. Again, you can plug in your own service to participate in this communication without impacting all the existing services. This is the workflow monitoring. So monitoring is very important. So the unique part of the Trident workflow monitoring is we do both locally and remotely. The user experience is the same. In this diagram, you can see we graphically display the progress of workflows, and then we also display the processing status for each activity. We also capture the input-output parameters automatically. And we display data products generated along the lines. We also do performance monitoring. The performance monitoring is for that workflow. It's not the overall system. For example, if we want to run this workflow, the performance will tell you for this particular workflow what's the CPU memory utilization. Management Studio. The Management Studio is really a combination of different components. And it has the administration of workflows and workflow scheduling and the registry management and monitoring. So administration of workflows, again, you can do locally and remotely. The user experience is the same. In this diagram, you can schedule a workflow to run at specific node. And you can specify what to run and when to run. So you specify the input parameters for the workflow. And you can also see graphically how the workflow looks like. And here you put the schedule. You specify what compute node you want to run. For example, in a cluster environment, you can specify which node in the cluster you want to run this workflow, or in the network, which computer server you want to run. And because we have a registry, we can export deployment packages. So that means we can dynamically push a deployment to a specific node. Again, monitoring is part of the Management Studio. Let me step back a little bit and tell you more about Windows Workflow Foundation. For those of you who may not be familiar with Windows Flow Foundation, it's a part of the Microsoft .NET framework. It was part of 3.0, and right now it's 3.5. And there will be upcoming version of 4.0. So each version, the library gets richer and faster. And this is why we're using the Windows Workflow Foundation, because we are leveraging the product team's constant improvements on the platform, and we can focus on Trident unique features. And a Workflow Foundation, if you look at it, it's a complex system, but it can be described in 3 words: activities, runtime, and tooling. So for activities, out of the box, it has a rich set of libraries that you can aggregate and inherit, and you can also develop your custom activities. And those custom activities are first-class citizens. And the workflow runtime covers persistent tracking, thread management, also transaction management. So there are a lot of services out of the box that are already being handled. So these are all challenging problems that we don't need to worry about, because the out of the box, the runtime already provides that capability. Most importantly, you can add and plug your own services given the software, given the workflow specification, and those services can immediately become part of the runtime, and then take advantage of all the other services. And Visual Studio comes with a designer. Visual Studio integrated development environment. With Visual Studio, it's really a general purpose development environment. You can develop workflows, but you cannot develop data-centric workflows. So, and that's where Trident comes in. Trident Composer is really considered as a rehosted designer. And again, this is really a reference implementation. It's not the only one. It's not the best one. If you have the code, you can customize it, and you can customize the way you want it. So these are the examples of Windows workflow library. So the difference between the basic activity and composite activity is really the composite activity is an activity. You can have more than one activities within a composite activity. For example, in a sequence activity, you can include one or more basic activities, and you can also include another sequence activity. So it's more of a hierarchical. But the basic activity handles a lot of basic things. For example, invoke web services. That's part of the basic activity. We don't need to worry about writing the details. And this is how we think workflows should be developed, based on the infrastructure we have, based on what Trident's tools are developed. So we have the base activities. From those base activities, we aggregate them, and we do inheritance. We also can developers can use Visual Studio to develop custom activities, and these activities become first-class citizens. And based on these activities, scientists can use Trident Composer to build domain-specific packages. And then those packages can be shared, and people can collaborate. Eventually, those packages become richer and richer and cover more and more domains. And so at this point, I think people, I'm done with all my talk. You may want to see more action, so I'm going to hand over to Jared. He's going to demonstrate Composer and Blackboard.
All right, everybody done with slides? I have two we're going to have to go through, and then we'll jump right into code. We'll see running code. This isn't just theory that we're working on here. I'm a developer, Nelson's a developer. We're going to be kind of diving a little more deeply, and we like to see stuff really running. So we're going to start with, we have four major components to what we're going to demonstrate to you. The first one is the composer itself. This is what most people will probably be looking at when they're working with Trident. It's how you build up from the basic building blocks, those activities, the workflow that you want to run. And it's also it's the interface that a scientist would want to look at as opposed to a developer. So just to clarify why we would want to do that kind of thing, this is a topic which we could spend a lot of time on, but it is important to note that the features that we're driving behind scientific workflow and Trident are based on this. Is the differences between what a business engine might want to see inside of a workflow versus what a scientist might want to see. You could think if you have an industrial strength workflow engine like Windows Workflow, why not just hand that off to the scientists and let them go? Well, that isn't enough. If there's activities, runtimes, and tools, I think we'll all agree that the building blocks, the activities, are going to be different for the various businesses or scientific communities, but also the runtime and tooling is too for these reasons. One is that in the business community, you've got this scenario where you really hardcore develop, you work on it, you debug a workflow, you get it just right, and then you deploy it and it runs over and over again. This might be your inventory tracking or whatever. In the scientific community, it's not that way. You want to run a workflow, and give it to the scientist, and then say he sees something interesting inside of there, but it's not quite exactly the way that your workflow worked. He wants to tweak some parameters, or she wants to, add a different kind of charting step for visualization on that. We want to provide a way so they can easily interact with that without having to jump into Visual Studio and be a programmer. Make that comfortable. The other thing is that data flow is very much first class inside of the scientific workflows that we've seen. And there's a concept of data flow inside of Windows Workflow, but it's really hidden. And it's just kind of the developer himself behind the scene kind of understands how that's working, and it's never surfaced. We wanted to surface that. The other thing we needed to do was to not keep that all internal to the company, that workflow, but to get it out there into the community, and we're partnering with people to do that. But we have to provide that support too. And then, of course, provenance, both in terms of editing your workflow and what the actual results happen to be. And this is my favorite because you need to adapt not only to the different computing environments, but also the different kind of computing users. I really like to work on user interfaces that are intuitive for people to use that don't require somebody who's been inside of a computer science school in order to work with them. This is a shot of what I'm going to show you, just a preview. As soon as this slide's done, I'm going to jump into it for the real deal. But this is the Trident Composer. It's made up of several sections. Right there, you'll see a library of all your workflows, the things that you're interested in. Could be when you install this, you're interested in oceanography, we'll pre-populate that with some of those. But this is where you put your workflows. What makes up your workflows is done over here. In the composition space, it's kind of your canvas for mostly dragging and dropping the elements in there. And the building blocks are those activities down there. They're categorized, and we'll show you how to get through them. Then, of course, with all the things that you can do on top of those workflows, saving them, exporting them, running them in a distributed environment, that's done at the in a kind of ribbonish control at the top. Okay, let's get out of PowerPoint and go into Trident. This is Trident. This is the real running version. I can't see the screen, so I'm going to have to look at my screen. Hopefully it's not cutting off anywhere. But it's just what you saw before. Let me show you this particular, we've we've tried to make it pretty easy to interact with. Yeah, I will. This particular workflow is pretty typical of a scientific workflow. The idea is that you want to read some data, you want to do something with that data, and then you want to, process it in some form, analyze it, and then you want to do something with that data. In this case, we're going to put it in a chart. The very first step reads from a NetCDF file. A lot of you might be familiar with that particular format. That's the kind of building block activity we want to give you, is the ability to read from a typical format that oceanographers, astronomers, whoever use. And then we put that into a binary format we call a hypercube. Now the processing step is actually done right here. Each one of these blocks, by the way, is an activity. The processing step right here, which you'll see, let me start back from the beginning. It reads an input file, which the input is this one right here. It says the NetCDF file to load. If we look at that, the values for each one of those parameters are in there, and you could actually set that if you wanted to, but here's the location it's looking at on my computer for a particular file. Okay? So you could change that. The scientist could change the input file without having to program anything. Just double-click on that, type it in. The output then is the schema that it reads from that, as well as the data object. From that, we turn those outputs, you see those lines coming out of the output side and going into the input side of the next one, is a process that turns it into a hypercube object. And then that hypercube object is then gone through another translation step, which takes it from a 4-dimensional object into a 2-dimensional object. 2-dimensional objects are easier to chart, so we take that data table and we pass it to an activity that actually charts the data table. Does that make sense? Does everybody understand kind of what's going on? This is a sequence. This building block executes until it's done. The second one goes until it's done, and so forth. Let me, yeah?
One question. When you compose these blocks, how do you know as a user that some of the parameters don't need any input and some...
We do have a notion of that. You might not intuitively do it, but as soon as we tell you, maybe it'll make sense. There's this sense of required inputs and optional inputs inside of these, and the colored in blocks, when that little triangle coming into them, if it's colored in, that means it's a required input. You're going to have to put a value in there. You could either type it in, or you can do a data bind to it. If it's not filled in, like a lot of these over here in this third activity, that means it's optional. It's something that you could set, and it might change it, but it'll probably have a default value that'll work too. Okay? And there's actually a validation step that it goes through. If you try and run it and you don't have required inputs set, this is something we get from Windows Workflow. It will warn you that this is an invalid workflow and you need to change in this activity. Yeah?
So I understand the concept of this, but I'm just curious, in the example you have up there, the input is going sequentially too. Like, I was wondering if input can, skip a block or not.
So the question is, does the data flow through the workflow? Does it have to go in order inside of a sequence? And the answer is no. Any one of these objects, the parameters in here, is its own separate object and can bind to any other object. The one limitation you have is it's type safe. So you'll actually see that there's colors in here. Let me, I'll bring up a little guide here. There's a, let me close this. Where did it go? Well, normally there's a key that pops up here and actually tells you, based on the color, what the type is. You can also get the same information just by, there's a lot of contextual information that you can get through the tooltip. It'll tell you what the type is. You can't match the purple to the blue, which means you can't make a hypercube with string necessarily. And it just follows the standard programming model that way. But we did want to surface it in a more intuitive fashion. That's what the colors are for. And we'll find out why that didn't draw. Okay, so interacting with it. Now that we got a kind of a sense of what it does, obviously scientific workflows can get much more complicated than this. The one we have for PanSTARRS has hundreds of activities inside of it, but this one is a little more easy to demonstrate. Let's just say we're working with this this particular workflow. We want to do something different with the last step. Let's just get rid of that. Are you sure you want to get rid of that activity? Yeah, that's okay. It goes away. Right now I've got that data table, and I want to see what can I do with that. Well, I know that I can either chart the data table, or I can and pop up a UI for it, or I could send it, have a chart generated and generate an image. Down here, I look in my activities, in the visualization section for charts, I see that I have both of those there. If I'm curious about it, I can get more of a description because the names actually look pretty similar. But I do want to use this chart data table. So I drag it over and I pop it into the section of the workflow that I want to use it. Boom, it pops in. It tells me what the inputs are. That data table is a required parameter. Like I said, it's filled in right there. Well, fortunately, we have a data table from the last sequence, so I can just drag that across, and we've got that connected. Yeah.
So we're looking at a workflow that you've authored already using the tools that you're talking about
Yeah.
earlier, right? And so as you said, this would be the scientist's view of it. Can you help us understand which parts of these are part of the standard activity library, for example, versus things that you customized for this particular workflow, so we can get an
Yeah. Well, there's no magic as to, yeah. We haven't defined everything we're going to ship out of the box. We're still several months away from actually shipping. We'd like to put together some packages that are useful to the scientists, which we're working with. And we're also open to feedback from the community, which is one of the reasons we come here, is to learn what would be most interesting and most useful for people. Things like this NetCDF reader you'll find inside of there. Things like charting, visualization libraries. We hope also to be able to say, okay, if you don't find something that's very interesting for you, but probably is for your whole community that you work in, it only has to be done once. You write up those libraries and you can share it at some sort of, either internally to yourself, something you host, or through a tool like at My Experiment. You can just make those available, and then people can get whole oceanography or astronomy tools to go with them. There's no magic. An activity in the end is a bunch of input and output parameters and one execution block of code. So those really need to be written by developers at some point, either by us or by you, but then they can just be reused. Does that help answer your question? Okay. Yeah. So going back here, we've hooked up this data output to the input, and we found out it wants to be a bar chart, but we can make it a pie chart to begin with. So we can just set that or change the width on it, whatever we wanted to do. And we actually have a way of distributing it so it could run anywhere that there's a workflow executor. Right now I've got it selected to go on my machine. And we're going to just by pressing this play button here, execute this workflow. Yes, for provenance reasons, I want to save it before I do that. So the executor is actually living in a separate process. It's a Windows service that's running separate to the composer, but it will get the information that it needs to. See, I just got this little toast message saying that the workflow launched. And you're actually seeing it as it progresses through there. And hopefully we'll see a data chart that's come up right there with the pie chart. The other neat thing about workflow is that it's not tied to any particular tool. This particular charting tool that I used is another research project inside of Microsoft. It's just some sort of animation tool for charting. And you could hook up any code you have in .NET, you could just wrap it with an activity and then make it highly available to your colleagues, as opposed to having them have to program against it. You just plug it in with the right data type and off you go.
So it means if I want to use a specialized visualization too, then code has to be based as a .NET frame, or?
The activities themselves have to be written in .NET code. But .NET code does also make it available to you to maybe call a web service or execute an executable on your machine. We've done both of those things internally. It's very easy to do.
So that means I can throw my data output to some remote machine, have like some specialized visualization tools.
Absolutely, absolutely.
That's what's cool.
Yeah. In fact, we'll show that in a few minutes. All right. So I'm going to just show you one more. I had a couple more to show you, but we're dragging in on time a little bit. Let me just start a fresh activity. And you saw all these in sequence. It doesn't necessarily have to be in sequence. We support parallel activities. So here's some of the built-in Windows workflow activities here. If we just drag a parallel one inside of there, you'll see that a parallel one just actually has multiple sequences inside of it. What I want to do maybe is generate 2 random numbers at the same time. So I do that. And then, depending on whether one is greater than the other, perhaps I want to do some sort of different computation. So I'd take an if-else in here, and I drop that in there. The condition is in this section over here. And what actually happens if it's true, it happens here, and if it's false, it happens right there. So let's, we want to compare those. Let's see, where's that? Oh yeah, you're right, there you are. So if, let's say we want to see if one's greater than the other, we'll drop that in, we get this. We can position that around the output from our random number goes into the input of that. Obviously, this will take two integers in, produce a Boolean result. We could do a lot more inside of here, but I'll just very quickly take this over here. The output of this becomes the condition to check. And then, you know, whatever you wanted to do. If you wanted to read one data product in the true statement, you'd set that one there. And a different data product in the false, you'd set that over there. Just resize this down. And then you'd change your data product ID and all that various stuff. The other one interesting thing you might want to see is that you don't have to build just from activity blocks. Say somebody's written a workflow that you find very interesting and they published it somewhere, but you want to try something new with it. You can actually go, after you import it in as a workflow instead of an activity, you can actually drag that particular workflow in as a subsection of your current workflow, give it a name, let it pop in. And there it is right there. You can edit it, whatever. But say you don't want to change it. You just want to take their results and do something with it. You can just collapse it down and not have to worry about that particular block taking up all your space. So those are the features of the composer. Yeah, we got a couple of questions, and then we got to move on. Can we import it? The Windows Workflow Engine has been built up to support BPEL. We don't have a mechanism right now to bring in BPEL, but we are actually looking at several formats we might want to use in order to just import things like web services and, you know, stored procedures and databases. BPEL is one of those we're considering. If we don't do it, we're also open sourcing this to everybody, so, you know, it's not all that hard to do in terms of the code, and we'll have this ready to be extended. Yeah?
How do you process multiple files in parallel?
All the parallel activity is done through Windows Workflow itself, so you just drop in a parallel. The question was how do you process multiple files? So you can just drop in parallel activities, put in their own readers in each one of them, and the Windows Workflow will take care of the parallel processing for you. Okay, there's probably going to be more questions about how everything works in here, but we got to move on a little bit to keep to time. We've got, this is just the first thing of 4 we want to show you. The next thing will be the back-end data store, which is done through the registry, and Nelson will be demonstrating that. So let me bring the slides back up.
Good afternoon, everybody. My name is Nelson Araújo, and I'm working as an architect in Trident. And my goal is to deal with the core components and all the data that Trident is going to host, process, visualize. We are trying to accomplish here a flexible data store. The idea is Trident cannot host and process all the data, and we understand that. So the idea is we are going to allow you to plug your own components, your own providers, and deal with the data in the way that makes sense in the business process. So for example, we know today that people are outsourcing to other providers like Amazon S3, for example, because storage is cheap, and you don't have to have a big data center to maintain. So we are going to provide ways for you to put that into your workflow management system and allow you to process that data, view that data, and manage that. So let's take a quick look again in the first picture that Dean showed you to begin with. So in the Trident architecture, you will see that we have a few components down the stack. right? So as was previously said, the registry is responsible for keeping track of the catalog of the system. So pretty much the registry is the one who helps control the system state. The registry and the data access and the data model, they have to be extensible and pluggable. So that's one of the words you hear a lot during the talk, extensible, pluggable. So everything here is done in a way that you can take what's there and put your own. So as an example, we have Trident right now working with SQL Server and CloudDB. But we are also working with an S3 provider, and they just plug naturally in. And if you want to build your own, so for example, if you have an XML store or an object store, you can go in and plug it yourself. That's why we have the extensibility story. So what is the Trident registry? So when we are building Trident, we noticed that we need a single point of truth for the system. Trident is a distributed system. So the idea is you can push computation to different nodes. You want to integrate with cloud. You have a mixed platform, many times crossing even operating system. You can have a host running Unix, a host running macOS. You can have a mainframe doing computation. And all of that has to be synchronized somehow. Right? To do that, the registry is helping play their role and working also as an arbitrator when modules and pieces of the system disagree. Right? So pretty much it's almost like a referee and dictating the rules and who is right, who is wrong at any point in time. The registry itself, we are trying to make it flexible. So that means is if you don't have to have SQL Server as your registry. You can have other providers. We built a few to start with, and they also work as a sample and reference implementations. But we'll go in deeper details how those can be built. So one key thing is, we are supporting Microsoft, but also non-Microsoft providers. We understand that the scientists, they work in a very mixed environment. And that's just the nature the way it is. A corporation, they decide, I'm going with system X, and they say, you know what, system X it is. The scientists, because they have to interact with other scientists, universities with other universities, they do different choices in terms of where the data is, who processes, and how they process, and that has to go to account. And that's one of the key differences between getting you, like Jared mentioned previously, getting you the business workflow and just say, hey, here you go do it. It simply doesn't work because it's very different the way a corporation deals with the process and the data and the scientists do. And we are trying to support the most common platforms and architectures today. So pretty much we're trying to cover the three big ones today with local work. So if you don't have a big environment, if you don't have hundreds of nodes, you're just one or two people trying to collaborate, you just have your laptop and the machine, or just your lab, or just one machine, Trident still works. It will not be a big burden that you have to bring a specialist, a certified Trident consultant to go install the system for you. You spend 3 months doing that. So it works for the little guy, but it will also work for the big guy. So like Roger mentioned, the pen stars, they are processing gigabytes of data, terabytes of data every second. So the telescope's taking pictures, and we have to process the pipeline. That's, I would say, there's one extreme of data processing. We also have the biologists working on a much smaller scale project, or a grad student helping the faculty, and we try to accommodate that as well. And we are not trying to really reinvent the technologies here. So this is not meant to be a replacement for other data abstractions. It plugs very nicely with them. For example, our XML provider uses LINQ. So there is nothing preventing you from using other abstraction layers if you want, and just plug them in. So why we have a reference catalog, right? So as I mentioned, you have a unified view of the resources. So by just look at Trident Registry, I know like a map of where the things are. We didn't pick something like Active Directory or UDDI as that because of first, not to impose requirements, but also trying to make the scale and the flexibility. So if we had to pick Active Directory, now I have to make you either have a Windows environment or a LDAP environment, which is also very hard to set up correctly. So those things are also taken into consideration. Trident also stores reference to internal and external resources. So we also understand that we are not going to catalog and store everything. Exactly as we said before, we have data sitting on S3, we have data sitting on CloudDB, we have data local. So we are not going to try to say, oh, you install Trident, Trident manages your data. No. Trident manages how you access your data and it helps coordinate that. The data still lives where it is. So, for example, you can ship your data to some processing, but you can also ship your process to your data and Trident to try to help you there. We also have a flexible provider mechanism to abstract external resources that was done part of our internship this summer. So here's a snapshot of our connection manager, just to have an idea what I mean by flexible provider. Right? So we ship out of the box the providers, and you can build your own. I will go in details what means build their own, your own. But the idea is you just plug a new provider that's showing this list. If that doesn't scale, the screen will resize and make sure it does. Also, even the UI is pluggable. So for example, when I switch between the providers, the screen and the dialogues and the look and feel and the behavior radically changes. That is a part of the extensibility framework. So we understand that there is a very different abstraction between cloud, SQL, local, and whoever is building the providers has that knowledge, and that knowledge has to be passed on. But I can't impose and say, oh, your provider has to have a username and password. What if your provider now uses certificates? Now I need a certificate picker, but I can't put a certificate picker because I can't predict everything you're going to need. So that's where this comes in. You can design even your own UI, and they just get plugged together with your provider. So Trident also has a registry management system. So this example here is just the prototype. Pardon for the not very fancy UI, but we are making this much nicer to look. This is just a rough prototype. And here you can see the core object that Trident manages. Actually, there are a few more objects, but the idea is Trident is able to catalog users, the namespace, so you can have your own ontologies, compute nodes, so you can define where and how your resources will run. Of course, Trident takes care of the jobs, concurrent executions. Data products. Trident, as part of the provenance story and the pluggability of the data, also tracks data, not just process. So that means is I can have an output of one processing becomes the input of another processor. And that's a concept Trident provides. Being a concept makes easier that when you try to reuse that, it simply provides the architecture for that. You don't have to go and when you try to make your data collaborate with somebody else's data, you try to come up with a protocol for that. Trident is trying to help you there. And of course, because we're a workflow system, of course, all your libraries and all your activity, everything goes to the registry to provide the distribution as well. So here's just another expansion showing how the jobs are tracked. So here's a few sample jobs. We have the pen stores, they just ran some time ago, not long ago, a stress test and ran 100,000 times just to make sure this also scales. So here I show you like a dozen jobs, but these also scale to hundreds of thousands of jobs, and there are ways for searching and cataloging that. So this view is just a simplified view. And also, once your job runs, your data product gets produced. So the charting that Jared was running before, once it's done, is also cataloged by Trident. So the idea is everything in Trident gets cross-referenced. And that's a very important concept because one of the things we found when we are talking to scientists is change is a part of the process, which is very different from the business side. Business is once you get your process done, you solidify and that's it. changing is really part of the science, because if they knew the answer, they didn't know to research, right? So, and they changed so much that we got testimonies that after 3 months, and I have to go back and revisit some data, I don't remember it. I don't have the tracking, all the necessary tools. Like, how did I get here? And then another little research has to come in, like, to try to investigate how I got there, because that data is lost. So for example, here, in this example, by just look at this chart, I know that this chart was produced by this job, that ran on this node, that was running by another workflow, and also those other objects was also siblings and produced along the way. And that's just the tip of the iceberg. Much more data is tracked even for the provenance, but here is just direct cross-referencing. So if I publish this object through a web service, and the user wants to know when you generate, how you generate, give me the workflow, I want to run again. I want to run with different parameters. All of that is naturally fitting into this picture because Trident is actually capturing all that data. And part of that is done via the data providers. So what they are doing, right? So the storage provider, as I said, is a way to abstract how your catalog is run. So the idea here is the data provider doesn't make any assumptions. There is no explicit contract on how you should really store. It's a true abstraction. And we try to make that abstraction very simple. So if you, in analogy, I have verbs and subjects. And I just send an order to the data provider and say, please store me this object. I don't know, I don't want to know, I don't know, and I don't want to know how, where. It's really, really your business. The only thing is, sometime later I will say, give me back my objects, and you should be able to do that. Right? So that's the only thing we have in agreement. The same for relationships. Right? So Trident needs to capture and track all that relationships and manage all that relationship. And to do that, we go and we have a few other verbs that say, relate this user with this workflow, and the user is the owner of the workflow. Relate to this data product with this workflow and say this was an input of the workflow or an output or a reference. So all those sentences that we are sending over are being tracked, and later on, of course, I need to be able to say, what were the inputs of that workflow, and the API should be able to get me back. And actions like delete and update and the other search and the other necessary to make a management system work. We also trying to make the developer's life really easier. So Trident has this data model, the abstraction layer. I don't know if you remember, there are 3 layers here. One of the layers which abstracts the data, it's actually not done by hand. We wrote a productivity tool that actually co-generates all of that. That is have a few advantages and does not impose anything. If you don't want to use the code generator, fine, you can write the code your own. But after you write the 5th object, you start to wonder, oh man, I really wanted to have a code generator, but you do. So, and that also helped me make perfect match between the data and the code, because the code generator also generates the schemas for the data. So for example, generates all the SQL catalog in a way that when I compile Trident, it just works. And helps in the reliability. So one of the things I want to really do is do a deep dive and show you that when I say it's simple to create a provider, it's really, really simple. It's not that I come here and say, oh, you can just create a provider and you have to have a team of 10 guys for 2 years to get that done. We really try to make it simple, and we are going to show you what it takes to do that. So you have to remember why we are doing that, right? So Trident reads and writes data from systems. You might have your own system in place already, right? So you might have your own management system. You want to read the data from there, or even store Trident data there. That's exactly what this is for. So you might have a group or division that has already many databases in, or have a way to manage their object that match Trident. So you go in and do that. So what really takes to create a provider is really those 3 steps. You go and create a new assembly, or extend an existing assembly. You create one class derived from a base class that we provide, that provides an abstraction layer and all the we're going to see that in a second, all the necessary methods, and you drop that DLL into the Trident folder. That's it. That UI that I showed in the beginning will automatically resize itself to accommodate your new provider, and will make all the necessary groundwork to make your UI show your look and feel and your business scientific process fit in, right? So let's take a look at that. So I will switch for a second to Visual Studio, so we can take a look what those interfaces that I'm claiming were simple, if they are really simple. So Trident has, in the abstraction layer, two object types. One we call simple object, and the other we call relational object. And they match exactly what I said before. You either have an object or a relation to two objects or more objects. So that's it. So here in the first section, you see what kind of objects Trident supports. Of course, an object can have reference to other objects and not just relations. So an object can say, I'm a namespace, and I have the owner, or I have children namespace. Those are tracked as well, right? And we have a storage class that is also used by the code generator to go and make use of the object class. So when I say I have a namespace, that's a concept Trident has, and that will reflect into objects. Of course, will reflect into probably tables in SQL, but that's just because I decided to put in tables. I could put files on the disk. It's totally up to me. Of course, I have a relational database. I will store the object relations using the relational database. But if I had an object database, I could just store the object directly, right? So that's exactly what this was supposed to help. So if we go, so remember I talked about the verbs and the subjects, right? So we define a set of actions your provider has to honor. Of course, they are simple, like add, delete, but there are also some components like get me all the objects, get me the root, get me an object by ID. So those are defined and are known by the developer. And actually, this is not a very big list. So just to make sure that we, so that's it. So actually, it's just one more to fit. So that is the list, right? So if your provider supports those set of actions, you're done. So you provide all that. Of course, if you don't provide search, I will not be able to search. So if you don't provide a feature, part of Trident will not be able to leverage that. But OK, if you don't want to search, you don't provide the search functionality. Then when I type something in the search box, say, sorry, I can't search because I don't provide. But it's as straight as that, right? So I can ask you, like, give me how many objects are in a specific. Yeah?
One question. This looks like an interface definition, but without parameters.
Sorry? Can you repeat the question?
It looks like an interface definition, but without parameters. It's just the names of the...
Yeah. Why we did that way? Because the interface between the both layers has to be fixed. I can't add code on the fly to depend on my object types. So when I'm calling from the upper layer to the lower layer, I have to say, store an object, and here's the data for the object. I can't add new parameters to the function call on the fly, because your provider down below might not have ... parameters, like, for example, C++ would have. But the actions has to be known. If you're not prepared to go and for example, tell me how many objects you have, and by chance I go ask you, you'll fail. So we know in advance what kind of actions you have support. For example, counting is one of them. So you know that at some point I could ask you how many objects of certain kind are. And you have to be prepared to tell me a number. So that's a contract we defined for that, and we are documenting that. Does that make clear why we did that? But this is just the first part, right? So the connection itself, which is the provider, those will be used by the provider. Those are not the provider, just like the parameters and types that will be used. So the connection itself is actually defined in this file. And your connection might have transaction, might not, right? So if your connection, for example, relational database has transaction, you support a transaction interface. If not, you don't implement that, and then Trident will behave differently. If you have a provider, of course, you have to give me some information about your provider. But as you can see, all the interfaces, they are usually fit in a screen. They are very, very simple. And we are trying to really, and it's deliberate, to make it simple, so extensibility is really possible. The more I add and try to, let's say, make fatter, harder it will be for people to start from scratch and build on their own. So that's what we covered right now. So how I would build one of those guys. So we also did a few other things. That was part of our one of our interns' project. And we are trying to see how we can actually abstract the data that's living outside Trident. That's a key component that differentiates the scientific workflow, that we don't have control of all the pieces of the data. We know where they are, and even have to have a fault tolerance story very strong, because we have so many different and heterogeneous environment that failures are much more common than a highly controlled data center where the admin knows everything that's going on. So we are using that to do basically those two things. We track the objects so we can know where they live, and we also allow discovery. So enable answering questions like, okay, I have this data. What workflows could possibly I use or combine to actually process that data? So I know, for example, I want to go from an SCGF file to a chart. That's the only two things I know right now. I'm new to Trident. I could use that data to say, okay, and Trident go and suggest, oh, I have this workflow that if you tweak a little bit might help you. Or vice versa. I have a workflow that came in that somebody asked me to evaluate. So, for example, I'm a reviewer in a journal, and I got a paper, and he claims that workflow solves a problem. I can go back to try to say, okay, what data I can use to validate that workflow? So it goes both ways. And to do that, we use data providers, right? So it allows me to abstract the external reference, as I said many times already. And also, because they are abstract and they are done in Trident natively, when you scientists go build your workflows, your activities, you can benefit from that. We don't have to guess where your data will be if you have a recovery story. Trident will try to track that for you. So for example, if you call web service, right? So let's say you put an activity and say, call the web service. And the web service is down. Your activity will fail. What a developer usually do, he goes put code around to try to mitigate what happens when that activity fails. Or the web service is down and something like that. Because Trident is help you track. Trident can check that and also give you an alternate web service that do the same functionality transparently. So when the activity goes and asks, give me a web service that processes blast. If your first one is down, Trident can get you the alternate one. So your activity code remains simple, which is a key to make it more reliable. The more layers you put, the more complex you make it, harder it will be to make it reliable. So the simpler, the better, right? And all that data knowledge will live in the registry, so you can query yourself. By programming, or just let the system query for you, or runtime service like we have, we'll see in a second, Jared will show you that, can also leverage that for you. So we have a fault tolerance that keep monitoring the system, and if something goes wrong, he can take action. Your workflow doesn't have to worry about that. And again, the word of the day, pluggable and flexible. So we can go right or wrong. So if we abstracted SharePoint in our internship because we want to make sure. So Trident is not just a piece of software, it's a platform. So I need to get you access to use Trident as a platform without, for example, playing with the UI. How we do that? We provide you 3 layers for doing that. You can do that in native code, you can do that in native code, And it can also do this via web services. So the idea is to cover all possible spectrum your developer will be possibly using, and then you don't have to start from scratch. So just plug exactly in the most convenient for you. You will see later that native was used to integrate with Cove, part of the NEPTUNE project. Why? Because their code was all written in C++. There was no managed code. So they either had to rewrite Cove to be managed, or we provided a bridge, and we did that, so the integration was much easier, right? And we try to see the ideas for that, right? So the .NET Manager is easier to use in terms of Trident, because Trident is actually built on .NET, but that's not a deterrent for using the other ones, just that if your code is managed, it's natural, just add a reference and you're good to go. Native API, anything that's not .NET, is probably much easier to use. And again, that's a choice you make along the way, and interchangeable. All of them can be replaced by the other. And the web services, especially this, if you are in a non-Windows environment, you can put Trident working as a web service, so you can call from non-Windows hosts. So if you have a Linux front end, or if you have even a Linux backend that needs data from Trident, you can use the web service API, so you can make that happen. Again, heterogeneous is one of the key here we're trying to address. Okay, so I'll hand back to Jared. He will talk about the Blackboard.
So I made a stunning discovery when I was early into learning programming. So this is several years ago. It turns out that when you're writing software, sometimes things go wrong. This is shattering to me. I was a teenager at the time, and it's perfection I thought was just all around me. Anyway, so we needed to do something about that inside of Trident, because in the end, workflow is software. And we're going to need to not only be able to respond to failures that happen, but also know something about those. Now, if you've been in software for a while, you know that for a simple application, it's not too hard. You maybe kind of figure out what might have gone wrong. You kind of know the whole system. You go in and maybe put in like a system.out.println, and you can kind of get, oh no, that's Java. Console.writeLine is for C# and kind of get the output. But that just doesn't work in a big distributed system where you don't know all the code. You want to have events that tell you what's going on. In addition to that, as I got into the company, all of a sudden they started talking about it's just not just bugs in terms of whether it works or not, but there's this whole thing called performance, right? So you want to actually know when things are being bogged down and why they're being bogged down. Is it that the CPUs are being pegged out, or is it memory is being pegged real hard and a lot of page swapping is going on? These are kind of things that the high-level scientist really just wants it to work, but if they see that, this is a lot slower than I thought it was, maybe they can hand it over to one of their computer science colleagues or students that are working on the project and do something about it. So what we've come up with is a system we call the Blackboard, and it uses something that's inside of Windows Workflow. So we're going to have to backtrack a little bit back to WF and talk about how Windows Workflow does runs a workflow. What happens is when you create a Windows workflow, it's defined somewhere, it's code that you've worked with. But in order to run it, you have to first create a thread, a process in a thread that's the Windows Workflow runtime. And you give it the instance of your workflow, and it goes and runs with that. So that happens in its thread, and it goes and manages all of that process. Now, it turns out alongside of that thread, there are a bunch of other threads, which they call the runtime services. There are a bunch of these that are built in for doing things like tracking of the workflow events, when they started, when they stopped, when data changed, things like that. But at the same time, you can actually add your own in. And these will happen concurrently with the execution of the workflow, and we can get the events that happen automatically or ones that you throw from your basic activities. Now, what we wanted to do is take that infrastructure that existed in Windows Workflow, very robust and very important to Windows Workflow, and use it inside of a system that we could make use of inside of Trident. that brings us to the Blackboard. The Blackboard, in the end, is a pub subsystem. You're probably familiar with that. It's a publish-subscribe system. That means you write publishers that send out events and subscribers that then take in those events. And it's distributed so that those publishers can be anywhere. On one computer where you have certain events being generated, on another computer you actually want to receive those. Why do we need that? Let me give you a scenario. In Pan-STARRS, we talked about that earlier. This is an astronomy project where they're taking huge data sets, basically maps of the known universe that we can see from where we are. These data sets are so big they don't fit on one computer. They have to take sections of them and put them in different computers. What does that mean? When you want to run a workflow to work with those, you probably are going to get the best performance by running that workflow where the data is and then stitching it together in another place, right? So that means all these different workflows, which are all part of one big overarching workflow, are being run at different computers. But it's really not very handy if you happen to have to go and look at what the eventing around all of those workflows are on each one of those different computers. It's very nice to publish it up to a central system. And the Blackboard allows us to do that. It allows us to do that in a pluggable way too. Not only are we providing you this kind of information about when activities started, when they stopped, when data changed, but suppose you're very interested in whether it was a full moon that night when you were running that workflow. If you want to write a publisher to publish that, that's fine. Whatever it is you want to do. Full moon, probably not a real common scenario, but there's a lot of very common scenarios that you might want to track, things external to a workflow and internal to your activities. In addition, the amount of activities, events that are being generated here is actually quite large. It's a very large volume of data, but they're fairly small events. So what we wanted to do is be able to have something in a distributed system that's very lightweight and can handle these very, very quickly. And that's why we put this together. To see what exactly is being passed around, there are Blackboard messages. And basically what these are they're buckets of name-value pairs. So in my system, if I have a particular workflow runtime event, this is something generated by the tracking services of workflow. I know that the whole message is called a workflow runtime event. Inside of it, I know things like the type was that an activity started. The idea of that activity was that it's a netcdf reader. What was the job? You can add as many things you want to as that. What they are, though, they're always strings. It's just name-value pairs and strings, and the title is a string. Some work that an intern of ours did this particular summer, Satya, he's actually here, he actually also showed a way that we could take that and not just have them as hard-coded strings, but map them to an ontology so that they make sense to the entire community. So imagine that you do have this workflow runtime event and you want to distribute it. That's the end goal. Here's the basic architecture. Now, there's a lot of entry points into the Trident Workflow Executor. That could be a web service. It could be the composer you saw before. It could be a lot of things. But in the end, it always comes down to the Workflow Executor, and that is making use of Windows Workflow. Now, the runtime services that are inside of there publish these events, and we want to do something with it. So you can imagine that a lot of the publishers will link into those particular events. But at the same time, you might have a publisher that has no link to it at all, but wants to publish a message across to the subscribers on the other side. In between, we have the Blackboard. The role of the Blackboard is to take the messages which come from the publisher and do the smart rerouting of them to the subscribers that are interested in that particular message type. So what it has to do is it has to do that rerouting by using some subscription information management, which is it's just a little lightweight data store that it has on top of it to know what type of events need to go where. And it also needs to be able to be a little bit fault tolerant, because you do have scenarios in a distributed environment where you'll have pieces that will come down. If they come down and they don't come back up again, there's not a whole lot you can do other than to report it. But it is also common to find things that go down for a short period of time and come back up again. Turns out we can use some available technology that Microsoft has to have a little bit of a lightweight queue to store those in. When it comes back up, we'll push them back over, and you don't have to worry about it. In order to do that, you have to have some logic in there on how subscriptions are managed. The responsibility of these subscribers is not only to say, okay, give me a message and I'll do something with it, but it also says, what messages am I interested in? And those are based on that title I showed you at the top of the message. It says, I'm interested in messages about events, and I'm interested in messages about provenance or something like that, right? As soon as the subscriber connects to the Blackboard, it tells it which messages it wants to know from the system in general. That's what this blue arrow is coming over here, the subscription information. The Blackboard then stitches those together and makes a set union out of them. And if any sort of change happened, whether if that's just, A, B, and C were already in there and you just wanted A and B, well, it stops there. But if it wanted A, C, and D, it has to change that set union, and then it has to go and update all of the publishers and tell them, well, I'm now interested in D messages. I didn't used to be interested in D messages. The reason we wanted to do this is that some of these publishers generate large volumes of messages. If no one on the subscriber side is interested in those messages, you're going to save yourself a lot of bandwidth by not pushing those messages along in the first place. Okay? So internally, let's stepping back again. One of the reasons we think that this is really important for us to work on this from Microsoft side is that there are teams of people working on the technologies behind Windows Workflow and in this case the Windows Communication Foundation. These are two of the three basic tenets of .NET. So it's we think a real attractive thing to be able to say we've got this small team working on a workflow system, but we've got these hundreds of developers and testers and working together on a system that's just business critical out there. We can leverage those things. So our Blackboard builds up on top of the Windows Communication Foundation, and all the features that they push into that we can make use of, as just the same way that the Trident itself very heavily borrows from Windows Workflow. So here's an example. Last slide before I actually show this example running inside of the Composer. Imagine that you have a tracking service going. It's getting the various events of whether an activity started, when it ended, when data changed inside of it. You may want to do different things with that data, so you can configure it as to whether it pushes out that data or not. In addition, you might want to know about the CPU and memory usage that's happening when those workflows are running. So in order to know that information, you actually not only do you have to spawn off a thread that goes alongside the runtime, but you actually have to spawn a separate process off that reads system information from your computer. You can do things like that and push them across as messages. That's what we do in this particular example. So let me show you it actually running and what we can do with that. We're going to go back to the Trident Composer. Let me just not work with this one. This is a workflow that we've demoed in the past. It works with a system that Nelson's going to show you in a minute. I'm not going to show you the end result, but what it does is it reads a very large piece of data, several megabytes large. So it takes a little while, it processes that data, and sends a message out to a visualization system. Well, we want to know just how much usage is going on when it's running. When we click play, it's going to go over to that monitor slide. And we showed you this before, but what's happening really behind the scenes when it's launching that workflow, in order to know that it's actually processing right now, is that messages are going to the Blackboard and being sent back again. The status is coming up here in real time, and in fact, over here, you'll see a chart that's being generated as it's being run as well, which tells you both the CPU usage amounts for each particular activity, as well as the workflow in general, and the memory amounts. Turns out I have a lot of memory on this system, and so it's barely pegging it. But it's very useful, you can imagine, to take a system that's distributed across a lot of nodes, percolate all of that information to one source, and know, if there is trouble, where is that trouble? In addition to this, we're actually adding a lot of features around fault tolerance. When exceptions get thrown inside of your activities, you might want to do something with that. The Blackboard will let you know, and let you know that to just halt your workflow completely, or jump into some sort of different code or workflow to do some sort of recovery from it. Okay. Now, does that make sense? Does this idea of a Blackboard where messages are being passed around, is that pretty clear? I just want to make sure we got that right there. Okay. Yeah.
You said, just confirming what you said.
Yeah.
Basically, the delivery is on the title is the only query field for those queries. That's sort of like a standard query is what you're subscribed to.
Right. Yeah.
Like the language is really just you're like matching that title, and that's the only query you can do.
Yeah. So the question is, just so I get it recorded here, is that what I said was basically that the subscribers can subscribe to messages, but based only on the title. And that's true. That's what we've done so far. Like I said, what we wanted was a really lightweight system. If you can come up with a scenario where that's not enough, then potentially we can look into it. But so far, from all the scenarios we've seen, we want simple string match and get that sucker going. You know. Okay. Well, come and talk to me, because I think that's great. Okay. I know that these pub subsystems have been used in several workflow engines before. It's not an altogether uncommon thing, but we wanted to show how we were doing it inside of Trident, and just show you how important we think it is to helping the process of working on a workflow. So yeah, I would love to talk to you. Yeah, go ahead. Yeah, in fact, if I go back to, let me go back to this slide back here. This section here was all done in WCF, but remember that these things are done through interfaces as well. There's actually interfaces on the subscribers, the publishers, and the Blackboard itself. So not only could you plug in whatever separate WCF interfaces into this, but you could actually even re-implement the system in a different distributed environment if you wanted to. Okay, so let's move on. Next. Our last kind of deep dive section is about some of the more miscellaneous tips and tricks that you can use when working with Trident. Okay. Where we are? We are here. Okay, so in the last section of going deep dive on how we are doing Trident and also how you can interface Trident with other systems, we put this last section. This section will not be actually will take a lot of time. So we have an interoperability story. We are trying to make Trident the backbone of the workflow processing, but we really understand that Trident can't solve all the problems. So we have to put that really, really clear. We're not trying to make a workflow system that will solve all the problems. It's simply not. We couldn't find a way to do that. So we are going with the basic that, okay, we are going to take everything that's out there that can do things better, we will leverage. So that's the motivation here. And for that, we are putting, for example, a Silverlight management console and execution environment. So if you want even to administer Trident or run Trident, and you are not in a Windows machine, or if you're on a thin client, you can. Right? So Silverlight runs on Linux right now. I think it runs on Mac OS as well. So if you have one of those systems, I think I cover now 96% of all the desktops around. So then you're good. So we are going to make this story really strong. As I showed you in the other section, we also provide you an API so you can use the Trident as a platform. Like this? So we're using Trident what was that? Okay. As a platform. And I will show you also how we are interfacing, and I have two concrete examples. So Cove is part of the NEPTUNE project that is part of the University of Washington efforts. And we didn't write Cove. They wrote Cove. It's their software. It's their baby. And as I said, it was all done in C++.
Actually, we had to switch system because it uses OpenGL as well, so I couldn't remote the desktop. And we also want to make Trident able to collaborate, so even cross divisions, cross university, and all cross country. So we need a way to make those awareness. So we are using right now my experiment as our social environment, but again, flexible is the key. If there is another social network that you want to plug Trident to, there are ways you can extend that. We just had to pick one, and we picked my experiment because right now have a strong workflow usage and knowledge as the use case. But again, this list is not inclusive. You can put your own, and I will give an example how. So let me switch now here for a second to Cove itself. So as we get that screen, so what Cove is? Cove is a visualization tool. That's not showing up. Okay, there it is. So Cove is a visualization tool to see oceanographic data. So it's kind of like a virtual earth where you can actually have your processing, and they have special features like track currents and depths of the ocean, things that are very specific to that domain. A biologist has no use for this tool other than say where the diseases happen, probably, right? But for them, is the core. They were using that prior to Trident. So how we can integrate, right? So we said that Trident can process your data and make your research, but then you have it to visualize. So we can do it in two ways. The workflow Jared showed you in the beginning would push a message. This guy is also a web services server, which could receive. But that also doesn't scale because you want to keep it running overnight. You want to go fetch historic data as well. So what they did with our help is they used the Trident native API, and they were able to put, what is the? They were able to put that little Trident menu over there. So what this Trident menu would do? So of course, it's the entry point to Trident, but we allow them to communicate and interact with Trident data stores, again, using the flexible data providers. In this example here, my data is living on local SQL in this machine, but of course, it could be remotely, could be on a remote SQL, could be anywhere. That's where the connection manager and the providers came, what we talked before. So if I go here and invoke Trident from their UI, we get the connection manager. So I have a few connection managers set up here, and if I didn't have here, of course, the things I showed you before can be leveraged. So I can go configure my own. But I have already preset here, so I can easily go and say connect, and I get my search bar. So the idea here is I want to look at data. Some data was processed in the past. I know Trident tracks. So here I'm just doing a simple query, but we have another way to do a more refined query. But for this example, they are just using the simple one because it was enough for them. If they needed, they could use the other types of query we're building that they could put more predicates. So here, what I will do is I will make a search for everything that's Cove that lives in Trident. And I got those three results back. So what this means is something processes data and produce data products that are referenced by Trident, not necessarily to live in Trident. This could, from this point of view, I don't know. I could know, but I don't want to know where the data lives. It really doesn't matter. So Trident is tracking those three data. I can tell you, in this example, they live in the same machine. But they could very well live in S3, live in Amazon. And we'll show here exactly the same way. And that makes it easier for even domains that computing science is not the core competency, right? So it makes sense for me when because my computer science background, talk about cloud and web services. But I'm sure nutritionist or for example, use a marine biologist, he doesn't understand computers that deep. So the more we abstract and make it easier for them, the better, right? So then what I can do here to make that interactive code is just, okay, I want to see that data. And what will happen is, Cove now invoking, again, the native Trident API, is actually able to go figure out where the data is, how to get, and actually go get the data and hand it off to the application. So in this example here, the application is Cove itself. Of course, Cove could have got that application and passed the reference to another. So you can imagine you have a scheduler in a Unix machine that every night go see if you have some data and do some processing. It would work exactly the same way. You go look if you have the data, and then you can do something useful with that data. In this case here, I'm just opening the data so I can visually see it. So those colored dots, although they don't make too much sense for me because I'm not an oceanographer, they mean the temperature of those points. It makes much more sense for the guys who understand that. I just understand how to get the data to them. After that, I really can't help there. So this is a simple example of how interacting Trident with other systems. We're really trying to make that a reality. And this also, again, is not an inclusive list. So this is just one sample, and there are others as well. So here's another example of Trident extensibility story, right? So we want people to be able to collaborate. That we already got the idea that collaboration, communication is one of the key things of the current science era. So here's an example of a real Trident workflow that we were able to package, like Dean said in the beginning, using an open standard, flexible mechanism, and push to my experiment, which is a workflow repository. You can find actually in my experiment other workflow repositories other than Trident workflow repositories. It was not made for Trident, again, existed prior to Trident. And we is a way to show you that we can even interact with things that already exist. You don't have to, I give you an accessibility, but you have to start from scratch. No, this thing was before, has their way to read and write the packages, and they wrote in an extensible way. They were able to read and display. So right here, you have it still uses the old look and feel. You saw Jared driving the nicer aesthetic look and feel. So this is the prototype look and feel of the workflow, information about the workflow, the type, and more data. You can find the author, what it does. You can reference the products, so you can see a sample what that would do in the real life, et cetera, ontology. So this is, again, something that exists prior to Trident, that Trident just plugs in. And we're trying to do that for pretty much every single point. Again, the word is flexible, simple, and extensible, right? I forgot for a second. So in our tips and tricks bag, we are trying to make also the recurrent work simpler. The same way we did a code generator to help the developer that you'll be eventually working with, because we are not going to cover all possible domain that science has. So if you have your own file format that no one understands what it is in your domain, you probably have to get a developer to go help you doing that. So we are also producing other productivity tools, for example, making it easier for you to interface and generate activities to talk to databases. Again, in a strong type way, so you reduce the amount of failures you have. Of course, you can generate a SQL statement and push it out, and then get the result set back and hope the next guy understands that, right? And if they don't, then you get a runtime error, and then you have to deal with that. Here, the idea you will use .NET strong types to actually help shield you from runtime errors. So these productivity tools will inspect the database and help you build custom activities, which today you have to, again, you don't have to use that. You can go manually, open Visual Studio and type and do everything yourself. It's not a requirement, but again, productivity to make you do faster, better, The same for web services and data visualization. Jared showed you a few visualization. You can go extend that. You can also build your own from scratch. Even if you have a system like Cove that is a visualization, is not even the same machine, you can push it out using the web services. So we are trying to make that also possible. So I will hand out to Dean. He will talk about our roadmap.
Thank you, Nelson. This is the last slide. I'm going to just talk about the history of Trident and where we are and where we're going. Our project is based on science projects, so our requirements are based on NEPTUNE, IRIS, LEAD, and PennSTARS. So these are the big science projects. We gather requirements. So we start with overall architecture, and then we divide the project into different phases. So we started the project on August 1st. So really think about just 4 months ago. And right now we're in sprint 3. We're on target. In this phase, we have completed all the features, actually. We're doing optimization, clearing out all the bugs to get ready for the next sprint. For the next sprint, we're going to focus on some activities like Nelson talked about, invoking web services and store procedures to make them easier. And we're going to do provenance. So we're going to follow the open provenance model. And provenance is a big area, and we're going to start from PennSTARS. So we're going to start use PennSTARS as the starting point, and then we're going to extend it. And we're going to implement the admin console. That's the component to schedule workflows, run workflows management, and remote monitoring. That's really utilizes the Blackboard, like Jared was talking about. So we already implemented into the composer. Now we want to make it as a standalone so that we can monitor workflows remotely. And then in sprint 5, we're going to focus on Silverlight-based composer. That means we will enable the composer, the workflow authoring through a browser. And right now we really try to finish the features on the desktop version, and then the Silverlight version will allow scientists to construct workflows through a browser. And then we're going to make sure this workflows can be deployed not only locally and also remotely. And we're going to deal with fault tolerance. So the target date is March 31st, and that doesn't mean we're going to release on that date. At least we're going to code complete. And then there will be some period to documentation, user education, and so forth. But definitely this gives you some ideas where we are and where we're going, and when we're going to release to the community. So I'm open to questions.
Or quality assurance of large data sets in your workflows?
So the question is, have we dealt with quality control of
Quality control, technical quality control, or scientific quality control?
We have been focusing on software quality in terms of the runtime bugs, make sure it runs fast. And in terms of dealing with that issues, we work with our partners, for example, PennSTARS and others. But we as a group, we haven't done much in terms of the quality of the data itself.
So only you did the quality controls for the software, but not for the, you didn't make any process changes or workflows that were concerned with publication or quality assurance of
No.
OSCE
We think that would be too almost domain dependent. Exactly what quality is seems to vary from domain to domain. So we have not been worried about that at this point. No. Good.
Well, except Catherine worried about that a lot with those last step data.
Indeed, she did.
And so indeed, it seems like there are some tools that do impact cross domains that would be very useful for flagging. I mean, the problem is all these temperature sensors that we've got out there.
So one of the
they don't always work.
So one of the things we talked about towards later in 09 is actually looking at could we harness all the knowledge we have from Catherine, David Heckram, and other researchers we have, Yogesh working closely with this data. We want a big starter kit of activities to do stuff like that. You know, has something drifted radically over time? Does a web service fail repeatedly? Thank you. Just to get this on the record. We will be looking at, do we have knowledge about individual pipelines for instruments, certain activities that could look at quality or drift of an instrument over time, to try to build up this library of activities. But right now, we know we have the knowledge, but we just haven't made the investment yet to say anything concrete. I should take that microphone if people have questions so we get you on tape.
Yeah, go ahead. Oh.
Okay. Does parametric studies or user interactions, does that come into your agenda? Because I don't see it here.
Parametric exploration for a particular workflow?
Or service or workflow?
Not yet. So we do understand. We've seen some work of Julian Freide and what they're doing with Viz Trails, where if you have an existing workflow, they almost have a wrapper that will wrap around the workflow. We've seen that. We've talked with her about that. It's not something we've added yet, but it is something we've certainly shortlisted. You know, if you have a running workflow, could you actually supply a whole parameter space? In order to support that, we've got asynchronous execution, so we can fire your workflows off behind the scenes. We've got a scheduler that will schedule it on time. We really just need to add to the scheduler a set of stored parameters and keep running through that list till it's done, and we track all the runs for you. So I think we're this close machinery-wise. We just haven't added the veneer on top of it to make it look, or to start driving it. Fair?
Yeah. Question over there.
Maybe related to that last point, but clinical workflows in particular tend to require human input. If you're administering a drug or if you need to sign off a form or something like that, are they part of the framework?
Yeah, the answer is yes. So we have two kinds of workflows. One is interactive workflows. Another is more of a background processing workflows. So we support both. So that falls into category of interactive workflows.
Anyone else? Any last questions?
We're going to be here also, the whole conference. So if you have a quick one.
I take it to play nice through SharePoint. So if you've got a SharePoint data management system, this will sit on top of WWF on SharePoint.
And also these presentations should be asynchronous.
Yeah, I have copies of the presentation on a USB drive, or if somebody wants to give me a USB drive, I'd be happy to copy that so people can take that with them. We'll also be pitching it up on our website when we get back on that I gave you the link for, so you can download it as well.
So the question was the SharePoint workflows, whether a Trident composer can author SharePoint workflows. We haven't tried it, but for SharePoint really has its own custom designer, just like Trident. Trident has its composer and a composer workflow. So with SharePoint, it already has the composer for you, and you can. It's a wizard. You can author workflow specifically for SharePoint. Well, if you really want, you can make workflows through Visual Studio. Because Trident Composer is not a programming environment. I won't. No.
The point is that SharePoint is an excellent tool for data management, for XML document data management in science. There's a parallel talk going on now where they build a tool around that. want to pause workflows between the two environments, or you might want to use these more data-oriented workflows in a SharePoint environment for scientists.
Yes. Yes.
Yeah, I can help clear out. So first, regarding the tools that showed up in my Windows expired, is that's Windows 7 actually. So it's not a legal copy of Windows, although I'm Microsoft. So now regarding the SharePoint, so for example, during the internship, one of our interns, Eranda, is actually also here. He made a data provider that interacts with SharePoint. So we can actually fetch data directly from SharePoint and store data directly from SharePoint. So in that exercise, what we did, our workflow store was actually SharePoint. And also we would use fetch data directly from document libraries, shared lists, contacts, everything. And those references got into Trident Registry. And then after that, workflows can just use. So I can go to Trident and say, run this workflow. And the workflow, I give a pointer to something in the registry. Oh, it happened to be stored on SharePoint. Trident didn't know at that time. In runtime, figured out, actually got a runs provider, say, okay, let's go to SharePoint to fetch that guy, brought it back, execute it, and then put the data back to SharePoint.
That's right. Kind of the best of both worlds, actually, because quite often the SharePoint workflows that are easy to write are the stuff that manipulates the documents you're storing, and then the scientific kind of data flow workflows you separately. So
exactly. The main goal for the SharePoint workflow is really to manage the data that's inside SharePoint. So if you want to go outside SharePoint, you have a hard time because the library of SharePoint workflows and the workflow activities, they are really target SharePoint, right? So what you do, you abstract that, take the workflow out of SharePoint, put it into Trident, and then you can read from SharePoint and write it to your web server directly. Trident will work with both, not even caring that was SharePoint. If it was SharePoint or local file, it really didn't make a difference.
Any last questions?
When do we drink?
I think it's at 7 o'clock, and I think we're all ready. Thank you very much for coming today.